Okay, so yesterday, I hope that you guys have finished watching the video, okay, and also answered the tutorial questions lah. Okay, basically yesterday what you were supposed to have learned was a new chapter, okay, which is called heat, and judging by our PDPR, it looks like I'm going to finish this chapter uh, before we go back to school lah, which is not very good news lah actually, because uh, this chapter, well, according to a lot of students lah, this chapter is probably one of the most difficult chapters, because on the surface it looks very easy, but somehow when students answer questions kan, it's always this chapter that students like somehow they just cannot answer lah. I also don't know why. Okay, this chapter is, how do I say this? This chapter there is a lot of terminology in this chapter lah. Okay, there are a lot of terms and there are a lot of new words in this chapter which you have to use. You cannot just like use like bahasa pasar or everyday language or things or words that you use every day to explain the things that are happening in this chapter. Okay, so like for example, yesterday you were learning about thermal equilibrium. Okay, so this is a very new word, especially if you've never heard this. But in the world of physics, when you say thermal equilibrium, right, everybody will understand. Okay, especially if you're a physicist, or if you're a scientist, lah. You know, when you talk about thermal equilibrium, sure people will understand one. Okay, but if you want to, let's say, explain to your 5-year-old brother or 5-year-old sister, you don't say la thermal equilibrium. Okay, you say uh, same heat or same temperature. Okay, or something like that lah. But unfortunately, in physics, especially if you're going to answer exam, if you want to do well in physics, you have to use the correct words. You cannot use the words that are for 5-year-old kids lah. Okay, you have to use words that are suitable for 16-year-old people like yourself. Okay, so get used to this because there's a lot of explanations in this chapter, and the explanations sometimes require you to use certain words which are very important now. Okay, so thermal equilibrium is a situation where there are two things that happen in thermal equilibrium. Okay, it's a situation where the net rate heat, the what is the terminology that I used in this one yesterday? The net no the
Net flow
yeah
of heat.
net flow of heat is zero. Is that what I used yesterday? Did I say zero or same?
Zero.
Zero. Okay, if it's zero, then it's net flow of heat. Okay, so net flow of heat is zero. Means when two things are touching, okay, when two things are touching, there's always going to be a transfer of heat. It doesn't mean that if something is hot and something is cold, let's say for example, this aircon controller, I got nothing better to do, then I go and panaskan the aircon controller lah. And then this one, this cover, I go and put it inside an ice box lah. It doesn't mean that just because this is cold, that it is not transferring heat over to this one. The moment two things are touching, there's always going to be transfer of heat. It is just that the object that is hotter will transfer more heat into the object that is colder. The object that is colder will also transfer heat. Okay, this is the single most important thing that a lot of physics students forget or they fail to understand. It doesn't mean that if something is cold, means there is totally no heat there. No? There is always heat. Okay, there is only one situation where there is something there's totally no heat, which we will not talk about in this subtopic. It is at the end. Okay, so even something that is cold, like ice, for example, there is still some heat inside. Okay, and so when something that is hot touches something that is cold, okay, there will always be heat transfer. The hot thing will obviously transfer more heat. the cold item, the cold object will transfer a little bit of heat, okay, into this. Okay, there must always be transfer of heat. Whenever there's a thermometer, for example, or whenever you put your hand on your forehead, let's say you have a fever, you put your hand on your forehead, okay, so your hand is a little bit colder than your this one, okay, so there's always going to be transfer of heat. Okay, so your head will transfer heat to your hand will also transfer heat to your head until you reach a situation where the transfer of heat is the same. The amount of heat my head is transferring to the hand is the same as the amount of heat my hand is transferring to the head. Okay, now when that happens, another thing also happens. Okay, when that happens, the temperature of both the items is the same. Because now the change of heat is the same. I transfer heat to you, you transfer heat to me is the same. So that means the temperature is also the same. So this situation we call thermal equilibrium. And if you think about it now, we use this thermal equilibrium almost every day in our life one. Okay, and this is something that I want you to research on for your homework today lah. Okay, and then the second thing that you're supposed to know is how to calibrate a thermometer. Let's say, for example, I give you a thermometer, but I don't have the, the lines yet lah. So how do I find the lines? Okay, it's a 3-step process, very easy. The first step is put inside ice, because you know that when it is ice, the temperature is 0 degrees. So the mercury will fall down until a certain thing, you mark there 0. Second step is put inside hot water. Hot water, we know that the boiling point is 100 degrees. Okay, so the temperature will rise until 100 degrees. Okay, then the third step is you divide 100 lines. Because bottom is 0, top is 100, bahkan. So you divide 100 lines, 100 lines, 100 lines. I mean, 1, 2, 3, 4, 5, 6, 7, all the way until 100. Okay, so this process is what we call calibrating. Okay, we use, those of you who are better in English, we use the word calibrate when we talk about, when we talk about computer stuff, we talk about programming. Okay, so you calibrate this, calibrate that. Okay, but basically that's it. Calibrate is just you want to know what is the lowest, what is the highest, and how many lines are there in between. Okay, that's basically what this subtopic is about. Okay, so after my very long introduction, I still see that there's only 15 people in this class. So I'm like, I need to fry all these 8 other people who don't know how to wake up. Okay, so what's going to happen is I'm going to call one by one to answer these questions. Okay, so I told you yesterday, I just want you to answer the objective questions. But if you have already answered the subjective questions, also good. Okay, I want to discuss all the exercise questions today. Okay, so this is the first question. Earth monitoring satellite falls into Earth's atmosphere at a high velocity and reaches at the sea surface with a high temperature. Now, after a while, the temperature of the satellite is the same as caused by the temperature of the seawater. Okay, so this is caused by what? Leong, can you answer this, please? C. The satellite and the seawater are in thermal equilibrium. Okay, very good. Yeah, you cannot unmute yourself, is it? So fast to unmute. Okay, never mind, fine. Okay, so these are situations where actually we think about it is very simple. Okay, but still, sometimes some people will still get this wrong. Okay, so be very careful. The key word is this. The temperature of the satellite is the same as the temperature of the seawater. So you must think, oh, this one is thermal equilibrium. Okay? All right, number 2. The diagram shows a metal sphere P at 80 degrees Celsius is immersed in a cooler liquid Q. So P is hot, 80 degrees. Okay, Q is the cold water. Okay, so thermal equilibrium is reached when, what is your answer? Mr. Chin, Ibis.
A.
A. Okay, temperature of P equals to temperature of Q. See, very easy, right? Wow, very easy. Okay, number 3, diagram shows 2 copper blocks, L and M, touching each other. L is 50 degrees, M is 30 degrees. Now, which statement is correct when L and M are at thermal equilibrium? Sudah thermal equilibrium. Okay, which statement is correct? Can I have Joey for this, please? I seem to be calling
D.
the JL people. D. Okay, net rate heat Net rate of heat flow between L and M is 0. Okay, sorry, for those of you who are wondering, this why is it so difficult for him to get this one? Okay, because last time in the old syllabus, this was not the word that we use, we use the rate of, no, we use the word, the heat flow is the same. Okay, but now in your new syllabus, I think they took out that sentence lah. So in my mind, I'm still, which one is it they use lah? Okay, so yeah, so okay. Anyway, okay, I just ignore what I'm saying lah. But this one, okay, net rate of heat flow between L and M is 0. Okay, which is thermal equilibrium now. All right, very good. Now, diagram shows an object A and B, okay, temperatures T1 and T2. The heat flows from A to B. Okay, if the heat flow is from A to B, you must immediately think which one is hotter. Okay, so this one is until thermal equilibrium is reached at a temperature T. Now, this is a very important thing. It says the heat flows from A to B, right? But does it mean there is no heat flow from B to A? There is. Okay, it's just not stated in this question. There is heat flow from B to A, except that the heat flow from A to B is very big. Manakala the heat flow from B to A is very small and very tiny. Okay, there's always heat flow whenever two objects are touching. It's just who flows more lah. Okay, so which relationship between T1, T2, and T, which is the thermal equilibrium, is true? Can I have Bernadine for this, please?
A.
A. T1 is more than T2 is more than T. Huh, are you sure? If T2 is more than T, okay, T1 is more than T2 is easy lah. This one is hotter than this one. Okay, but if T2 is more than T, means this T2, sorry, hold on. Oh, that means this T2 is hotter than the thermal equilibrium temperature. Okay? Yeah. Is that true? Or that means this T1 is bigger than the T1 is higher than, what am I saying? Okay, sorry, the answer is actually C. T1 is more than T, correct? Because this is the hottest object. It becomes cooler. Manakala T2 is actually the coldest object and it becomes hotter. Okay, so sorry, Bernadine, your answer is not correct lah. The only one that you got correct is T1 is more than T2. That's correct. But you have to think, T2 actually the temperature is increasing because it is receiving more heat. So it's going to get hotter, okay, until it reaches the thermal equilibrium temperature. Okay, so this is actually the correct answer. Be very careful with this now. This is a very common trick question. Okay, number 5. What is the concept used in the measurement of a human body temperature using a thermometer? Okay, this is the best example, okay, of thermometer. Can I have Nordiana for this? I have not heard from Nordiana for such a long time. Do you know what is the answer to this question? C. Okay, thermal equilibrium, obviously lah, kan? Okay, because you haven't learned A and B. A and B is two different concepts lah, but this is very important. When you put a thermometer into your mouth, well, last time or into your armpit or into wherever you stick your thermometer into, there's always going to be transfer of heat. Remember, as long as two things are touching, even your two hands, when they are touching, there's always going to be heat flow until they reach the same temperature and the net rate of heat flow is 0. Okay, remember this. Next, what is the temperature of the metal sphere? Oh no. Okay, yeah. What is the temperature of the metal sphere when the thermal equilibrium is achieved between the sphere and the liquid? Okay, the metal sphere is 90 degrees, it's hot lah. The liquid is 40 degrees. Okay, so what is the temperature of the metal sphere? Okay, can I have, let's see, Vion,
Dog.
dog. Okay, very good. Between 40 and 90 degrees. Okay. Okay lah. Yeah. Good. Okay, between 40 and 90 degrees. Okay, it will be there. Good thing they haven't asked you to calculate, right? Okay, yeah, because that's the next subtopic. Okay, diagram 11 shows hot water being added to cold water. Okay, so this is the same thing, thermal contact. So which of the following statements is correct if there are no heat losses to the surrounding? Okay, if you printed this out, I want you to highlight this word. Okay, this is a very common sentence that we will see in this chapter. Okay, everything that we learn in this chapter, we assume that there is no heat loss to the surrounding. Because if you think about it, any object actually is always touching the air. And just now I said, if there are two objects that are touching, if there are two objects that are touching, okay, sure got thermal contact. But if you think about it, any object in the air is always touching the air. And since this object is touching the air, sure there must be this one transfer heat to the air and air transfer heat to the object. Okay? So whenever we talk about thermal equilibrium, later when we do all this calculation, everything, right? This is a very important assumption. Assumption andaian, okay? Ini satu andaian yang sangat penting. There is no heat loss to the surrounding. Whenever we do calculation, whenever we talk about thermal equilibrium, we assume that the heat loss or the heat exchange is only between the two objects. In reality, there is heat loss to the surrounding because the object is touching the air. Okay, so if you printed this out, please highlight this and write down the word here, assumption. Okay, it's a very important assumption. Okay. I didn't put my pen today. Okay, assumption, fine. Okay, so what is the answer for this? Which of the following statements is correct if there are no heat losses to the surrounding? Junie?
C.
C. Okay, heat loss by hot water is equal to the heat gain by cold water. Okay, very good. All right, number 8. Diagram 12.1 shows hot water being poured into cold syrup. Diagram 12.2 shows the final mixture. Wow, hot water inside cold syrup. Okay, how many of you do this? And most of you put cold syrup into hot water, correct or not? Sorry, I don't know lah. Actually, I was taught that this is the correct method. When you put the syrup first and then you put the hot water. But actually, in actual fact, usually you put water first and then you put the syrup, right? I don't know. How many of you, I mean, think about this. Like say, for example, you make Ribena. And when you make Ribena, do you put the Ribena first or you put the water first? Let's say if you make Milo or Nescafe, this one is easy. You put the Milo first and then only you put the hot water, right? That's normal. But for syrup drinks, actually you're supposed to do the same way. You put the syrup first and then only you put the water. Most people, they put the water first and then they put the syrup, which is like boom. Okay, so this one I learned very recently. Apparently, it makes the drink more delicious. I still don't know. Okay, so which statement is correct about the temperature of the final mixture? Okay, temperature of the final mixture. Is Rahman here? Rahman, boleh jawab tak ni?
Dog.
Oh, dog. Okay. It is the same as, salah oi. It is lower, okay, lower than the temperature of the hot water. Cannot be the same as the temperature of the cold syrup. Because when you put hot water into the cold syrup akan menjadi panas. Okay, so it will never be the same as the original temperature. Okay, it will be somewhere between the hot and the cold. Okay, so please remember that. All right, good. Number 9. Diagram 10 shows a cup of hot coffee, just like what I'm having now. So what happens when the coffee and the cup are in equilibrium? So the coffee inside the cup is touching the cup. Okay, so think about this. The coffee is hot. The cup originally is not hot lah. But when you put your hand on the coffee, you're like, my cup also become very hot. So what happens when the coffee and the cup are in thermal equilibrium? This is the question number 9. By now, we should be able to answer this. Can I have Is Iril is not here. Nikki, can you answer this, please?
A.
A. The temperature of the cup is increasing. Thermal equilibrium sudah. Oh. If it's thermal equilibrium sudah, what do you think? A is definitely not right lah.
C. Wait, no. I'm not sure.
Okay, the answer is C lah. There is no net heat flow because the question says already in thermal equilibrium. If the question now, what happens when the coffee and cup are not yet in thermal equilibrium, right? Then A also is correct. Temperature of the cup is increasing. B also is correct. Temperature of the coffee is decreasing. And C, there is a net flow from the coffee to the cup is also correct. But the question asks already in thermal equilibrium. Okay, so there is no net heat flow because the coffee is transferring the same amount of energy to the cup and the cup is transferring the same amount of energy to the coffee. Okay, be careful of this. All right, number 10. This is a calculation question. So 5 centimeter, 25 centimeter, when the thermometer is placed in the liquid, the length of the mercury column is 12. Can I have Carlson to answer this, please? What is your answer?
B.
B. Let's check. Okay, so yeah, the answer is 12 minus 5, 25 minus 5 times 100, you get 35 degrees. Okay, so the answer is B. Very good. Okay, if you don't know how to answer this, I explained this in the video yesterday, how to do this calculation. It's a very simple calculation. Okay, the length that you want minus 0 over 100 minus 0 times 100 degrees. Okay, which liquid ABCD can be used to make a liquid in-glass thermometer to measure temperatures from negative 50 to 50 degrees Celsius? Okay, so not all thermometers are actually used, not all thermometers are like 0, 100. Okay, not all. So some thermometers, they are special. They can measure until negative 50 degrees Celsius. So we need to choose the correct liquid inside the thermometer. Okay, if you watched the video yesterday, I said that inside our normal thermometer, the liquid that we use is mercury lah. Okay, because there is a certain freezing point and boiling point. So which one is the correct pair? Who else haven't I called? I seem to have not called a lot of people, kan? I think I have finished calling everybody. Have I finished calling everybody? Okay, Ari, 11. Which one is suitable? Which one no calculation one? Just think with me. You want to measure negative 50 until 50.
A.
Okay, the answer will be obviously A lah. Because anything else, if you, let's say you go into negative 49 degrees Celsius, this thermometer will freeze already. That's why it's called a freezing point. Okay, good job. So that's why it's called a freezing point because anything below negative, this one, it will already frozen. And if the liquid inside the thermometer already frozen, then the thermometer is useless lah. It cannot go up and go down. Okay, all right, good. Number 12. Wow, is this the last question? Okay, which modification will increase the sensitivity of the thermometer? Sorry, I just need to double check. Did I cover this in my video? Did I talk about the sensitivity of the thermometer? Mr. Wong, can you answer this, please? Oh, I did. Okay, so fine. Mr. Wong, then you answer this. Which modification will increase the sensitivity of the thermometer? Sorry.
D.
B. Okay, sorry, did you say B or D? Okay, never mind, I give the answer. Okay, it's D, using a narrower bore. Okay, I think there are either 3 or 4 modifications. Okay, that if you want to increase the sensitivity of the thermometer, my advice to you is to remember these modifications. Okay, because it's it's not that difficult lah. Okay, how many more questions are there, my goodness. Okay, sorry, number 13. I'm going to give the answer straight. The net rate of heat flow between M and N is 0. The reason why I'm rushing through this is because I want to answer the structured questions, okay? A cake is placed in a hot oven. The temperature of the cake is the same as that of the oven after several minutes. Okay, after 13 questions, you kind of know that, okay, this is thermal equilibrium. Remember that the key word is the temperature is the same. Okay, temperature is the same. Net rate of heat flow is 0. These are two very important words that when you hear these words, thermal equilibrium. Okay, think about this. Wow, how many? Sorry, number 15. Have I called everybody? Who else? Oh, okay, fine. Elvin, number 15. Okay, Elvin say A. Reading of thermometer P is more than reading of thermometer Q. Okay, very good, correct. Okay, obviously lah, because Q has apa ini? Both because are heated with the same energy. Okay, because P will increase temperature faster. Because it's less water. Q will take a longer time to increase temperature. Okay, good. Okay, okay, sorry. Statement is correct. This one don't need to think lah. Soup and this one has same temperature. Now, guys, look at this. Look at the C answer. The C answer is no flow of heat. What is the missing word in this answer? The answer is no net flow of heat. Okay, so be very careful with this. I'm repeating this so many times because trust me, until exam, right? Sure, got some people are gonna trapped by this kind of question. Thermal equilibrium, same temperature, net rate of heat flow is 0. Okay, so this answer C is wrong. No flow of heat between the soup and the spoon is wrong. No net flow of heat, baru dia betul. Okay, it is a trap. Those of you who answered C, okay, please mark down there. Why is the C answer wrong? Because the word net is not there. Okay, this is a very common trick question. Okay, I always see a lot of students gonna trick because of this. Be very careful. Okay, which statement is correct about the heat flow? Okay, obviously the answer is this. Net heat flow is 0. Okay. How many objective questions are there? I thought there were only 15. Okay, diagram 10 shows this. Which statement is correct about the coffee? Obviously, heat lost by hot coffee is equal to the heat gained by the surrounding. Okay, I'm just going to leave this here. All right, let's do this. This is the structured questions. I'm going to we're going to answer this. If you printed this out, then you can write this one. If not, then I suggest you take out a piece of paper and write this, because actually this thing has already been photostated for you. It is just that the photostat is in school lah. Okay, and we can't go back to school to collect it yet lah. Okay, so just write down the answer, and then after that you transfer your answer into the book. Okay, when you get it. All right, so state the physical change in mercury when the temperature increases. Okay, the physical change should be the volume. Okay, what happens to mercury when the temperature increases? Why does it go up the thermometer? It's because it is expanding. Okay, it is expanding because of the volume lah. So why is mercury used in the thermometer? Okay, because, okay, so there's all this lah. It does not stick to glass. It expands. Okay, I want you to add another word over here. Expand and sorry, my horrendous handwriting. Okay, expand and contract uniformly. Okay, expand and contract uniformly. Okay, this first two is for me the most important feature. Why we use mercury inside a thermometer? Because number one, it does not stick to the glass. Imagine if you use oil inside the thermometer. Oil is very sticky one. So when the oil goes down, some of it will stick at the side, and that's a very big problem. Okay. The second reason why we use mercury inside thermometer is because of this special feature. When it expands, it expands uniformly. When it contracts uniformly. It means the whole thing expands at the same time, the whole thing contract at the same time. It doesn't sikit-sikit, this side expand first, then this side expand, then this side expand. It doesn't work that way lah. Okay. The third reason is because this word is called opaque. Okay, opaque dalam bahasa Melayu, opaque maksudnya dia legap means you cannot see through the liquid. Okay, for example, you use water lah, right? You can see through water. If you see through water, and it's very difficult. How are you going to see the reading? And but because mercury, the color is like silver, right? Okay, so we say it's easy for us to see the reading because it is opaque. Okay, you don't have to like put it to the light lah or whatever. You just read it there and there. You can see it already lah. Okay, so these are the three main reasons why we use mercury inside the thermometer. But for me, the most important reason is this one. This is number one. Then this one is number two. Baru this one is number three. Okay, the most important reason is because it expands and contracts uniformly. All right. What is the difference between the lengths of the mercury columns at 0 degrees and 100 degrees Celsius? So the difference is very easily counted. It is 20 cm lah. Because 100 degrees 22.6 cm. 0 degrees 2.6. So dia punya perbezaan panjang is 20. Okay. Now this calculation you can do using the formula that I taught in the video yesterday. Okay, you will get the answer 71.5 degrees Celsius. Just jot down this one first, and then you can just do a little bit of revision later on how to do the calculation lah. Okay, the answer 71.5. Okay, diagram 1 shows a thermometer used to measure the temperature of hot water. Am I getting this set of questions wrong? So weird. How come this is number 1? Okay, name one type of liquid used in the thermometer. Obviously, usually we use mercury, sometimes we use alcohol. You know, sometimes there are certain thermometers, right? Inside the thermometer, the color of the liquid is red color. So the red color liquid usually is alcohol. Alcohol, and then they put some coloring inside lah. Cause alcohol kan they're colorless. It looks like water. So they put red coloring so that you can read this one. So certain I don't remember where's my. I think I have a house thermometer somewhere in my house. Okay, the liquid is red color one. Okay, but the liquid is alcohol Okay, they put red coloring inside. Okay, so give one reason so all these reasons also can expand and contract uniformly, does not stick to glass, it is opaque, okay, it has a high boiling point. Whether or not you use mercury or alcohol, generally both has a high boiling point. Okay, but mercury has a higher boiling point, much higher. Okay. Next, complete the following sentence by tick the correct answer. Okay, the temperature of the water is taken when the liquid in the thermometer stops expanding. Obviously kan. When we put something inside, then we wait for a while because the mercury inside the thermometer has to expand. Until it stops expanding, baru kamu ambil bacaan. And this one is something that you learn since Form 1. Nobody put the thermometer inside the water and then immediately start to read. Oh, 37 degrees, 38 degrees. Oh no, wait, 41 degrees. Oh no, wait. Right. You wait until it stops expanding. Then only you take the reading of the thermometer. Okay. Now, the correct word to use, everybody, the correct word to use is expanding. Okay, although when we teach, other people, okay, wait until the thermometer stop moving, then you take the reading. Okay, come on guys, let's use the correct word from now on. Wait until the mercury stop expanding. Okay, not the thermometer stop moving. Okay, so name the physics principle involved. This is obviously thermal equilibrium. Okay, it has to stop expanding. It is expanding because there is heat flowing into the thermometer. That's why the mercury is expanding. So expanding, it will go up until it stops expanding. Then you take the temperature. All right. Next question. So diagram 8.1 shows an uncalibrated. So this is the calibration of thermometer question. So as I said just now, calibration of thermometer very easy, you know. Put inside ice, put inside water, mark. Put inside ice, put inside boiling water, mark. Okay. So inside ice is 6 cm. Inside the boil until 100 degrees Celsius, and then after that, at this one is 20 cm. Okay, so this one is 16 cm. Okay, so you kind of know how, if you know how to use the formula from yesterday's lesson, okay, then this will be a very easy, that you kind of know how to find out what is the measurement of this temperature. So temperature, is it a base quantity or derived quantity? Is obviously a base quantity. Teacher Fiona would have taught you this. Okay, now determine the difference in the length of the mercury columns. Is very easy. The difference is 20 minus 6, so it's 14 cm. Calculate the temperature by using the formula that that you learned yesterday. So the temperature of this will be 71.43 degrees Celsius. Okay, now this is a very common question asked now. What will happen to the boiling point of the water if it is boiled on top of the mountain? Okay, and I don't know how many of you have ever climbed Mount Kinabalu, but if you have ever climbed Mount Kinabalu and you've tried to boil water on top of Mount Kinabalu, you will find that it is much easier to boil water, okay, on top of the mountain as opposed to when you're on Earth. Okay, so there is an explanation for this, which I want you to do a little bit of research. Okay, why is it that when you go to the top of the mountain, okay, the boiling point is lower? Okay, it is faster to boil water, okay, on top of the mountain, rather than on, if you're like at the bottom of the mountain. Okay, so this is one assignment that I want you to do today lah. Okay, we'll talk about this in a little while. All right, so this is a diagram that shows 4 different types of thermometers. Okay, and this is the characteristics of each thermometer lah. So we find that P can measure from 0 to 100, Q can measure from 30 to 45. Diameter, some small, some big. Accuracy 0.1 and 1. Okay, now accuracy means that this P thermometer can measure 0.1, 0.2, 0.3, 0.4. You know, they can measure 37.1, 37. Dia punya accuracy sampai 1/40. R and S, since the accuracy is only 1, means it cannot measure the point. It can only measure 37, then the next one is 38, then the next one is 39. Okay, so when you think about it, P and Q, these two are more accurate because it can measure more decimal places. Okay, so choose the suitable range of thermometer to measure the body temperature of the patient. Okay, the answer will obviously be 30 to 40 degrees. Okay, or the low range lah. Okay, and the reason is the normal temperature of human. What is the normal temperature of human? How many of you know this? We have taken temperature so many times in the shopping complex in the supermarket. If until now you still don't know what is your normal temperature, people, can you answer this? What is the normal temperature of a human? What is the body temperature? Suhu badan yang biasa.
36 to 37 like that.
Okay, 36 to 37. Yeah. So this is something that especially chemistry, chemistry and bio, you will always know this. Body temperature must always be hotter than room temperature. Room temperature is 27. Okay, body temperature is 37. Because think about it, what happens if the room temperature is hotter than the body temperature? what's going to happen? The room heat is going to flow into the body, which is not a good thing. Okay, so you want the heat from the body to always flow out into the room. Okay, because our body, Amy, think about it lah. If the room temperature is very hot, right, heat will flow inside our body, and then our body will become hotter. When our body become hotter, what will happen? You will be quarantined. Okay, so remember, body temperature 37, sorry. Room temperature is always 27. Okay, chemistry, you learn this lah. Okay, choose a suitable diameter of the capillary tube. We want a smaller capillary tube. Okay, and the reason for this is so that it is more sensitive or detect small change. Okay, so I explained this in the video yesterday. All right. Next, choose the suitable accuracy. Obviously, the better accuracy is the 0.1 degrees Celsius. Okay, because it is more accurate. You can also say more sensitive. Okay, also can. So let's think about this. Based on the answers, choose which suitable thermometer to determine the body temperature of the patient. Okay, what is the characteristics? We want 30 to 40. Okay, so we want this kind of temperature. We want small diameter. So this is the small diameter. Okay, and then we want 0.1 degrees Celsius. Astaga, sorry, this one, and this one. So among PQRS, which one fits all three? Okay, so you see that actually, okay, Q is the best luck because all three suitable characteristics are there. Okay,